In this video, we're going to learn about the gas laws. So there are a few different gas laws that really can be put together to be called the combined gas law. This is the most complex one, but the other ones can be taken from this one, and I think it's best to start here. The pressure, temperature, and volume of a gas can be related by this equation: P1V1 over T1 is equal to P2V2 over T2. This is essentially saying that if we have a gas at a certain pressure, volume, and temperature initially, and we change something about it, let's say we raise the temperature, well, then the pressure and the volume will change according to that change in temperature. And it's possible also to hold a variable constant. For example, what if we have a closed container with really rigid walls? In that case, the volume is going to be held constant. So we could actually directly calculate, say we have an initial pressure and an initial temperature. If we raise the temperature, what happens to the pressure, assuming the volume doesn't change? Let's put this into practice. So the first gas law is called Boyles Law, and that is when we hold temperature constant. It relates pressure and volume when we have a temperature that is held constant. So if the temperature is held constant, what we can do is we can take that out of the equation. We're dividing by the same number in both cases on the left and the right, so they cancel out. So Boyle's law is simply P1V1 equals P2V2. And what this means is that if we have an initial pressure and volume, and we change the volume, the pressure will either raise or lower. Let's see what we have going on here. Our initial pressure, I'm going to say that this is about 4.25, sorry, our volume is about 4.25 liters, let's say. So our initial pressure is 1.00 atmospheres, and that's what we see here, the initial pressure. And we're going to say that we have 4.25 liters, and that's equal to our final pressure, which is 1.33 atmospheres, times, let's say that I can't read this. Let's say it's a little foggy here and I don't really see the volume, but I did know that the volume initially was 4.25 liters. Well, let's say I'm then solving for V2. If I were to multiply these and then divide by the 1.33 atmospheres on both sides, what I would find is that my volume 2 is equal to, let's see, I need 3 sig figs. It's equal to 3.20 liters. That would be my final volume. Now let's consider Charles's law. Well, what's going on here is we have something where a volume definitely changes. We start off at negative 65 degrees Celsius and we go up to 250 Celsius, so our temperature is changing. But as our temperature changes, our volume changes. Now, we're going to assume this is at constant pressure. So since pressure isn't changing, we have pressure taken out. V1 over T1 equals V2 over T2. Our initial volume divided by our initial temperature is equal to our final volume divided by our final temperature. Now, in this case, I really want to point out that this will not work unless you convert your temperature to Kelvin. In everything involving gases, any gas calculation, you must convert from Celsius to Kelvin. Otherwise, you'll get things that absolutely don't make sense. For example, our initial volume is some positive number divided by an initial temperature of negative 65 degrees. We'd have a negative number on our left, and on the right side, we'd have a positive number. So it just would never work. So just understand that you need to take the Celsius and add 273. 0.15 actually, and that's going to give us our Kelvin. And the same thing over here, 250 plus 273. So that's Charles's law, and you do calculations with Charles's law similarly to how you would with Boyle's law. Gay-Lussac's law, here's our third gas law. This, as you can see, we've got an ice bath, so the temperature is one thing initially, and you can see that there's a measurement of pressure. Notice that when we boil the water, the pressure increases. The molecules move faster, they collide harder with the container, they're going to increase in pressure as they are getting hotter. This is done at constant volume because the flask is not changing in size. So our volume, our V2 and our V1 are taken out, and we get P1 over T1 equals P2 over T2. And for this one, I'll just do a calculation again because it's kind of already there. We'll find that our pressure initially is 1.00 atmospheres. Our ice bath, let's just say that we don't know what the actual temperature is, even though an ice bath is going to be at 0 degrees Celsius or 273 Kelvin. And of course, it's the 273 Kelvin that we would calculate. We have 1.37 atmospheres as our final pressure, and that's divided by boiling water. Well, we have 100 Celsius is boiling water. 100 Celsius plus 273 is going to be 373 Kelvin. So we have 373 Kelvin. And if we do out the math, what we're going to find out is that our T1 is equal to 273 Kelvin. And this is done with the right number of sig figs, 3 sig figs for the measurement. And of course, 273 Kelvin is 0 degrees Celsius, which is what you would expect from an ice bath. So long story short, we see that pressure increases with temperature. They're directly proportional to one another. Also, volume increases with temperature. They are directly proportional to one another. As gases get hotter, they expand. And then also, if the volume changes, it changes with inverse proportionality to pressure. As something is allowed to expand, the pressure decreases. If you compress something, the pressure will increase. And those are the 3 gas laws. Of course, they do come to a combined gas law, but bear in mind, if you were to use the combined gas law, in order to solve for any one variable, you would need the other 1, 2, 3, 4, 5 of them. Hope this has helped, and let me know if you have any comments or any questions in the comments box. Thank you.